Let's calculate for the ceiling fan. Rated 80 watts. You have to convert that to kilowatt per hour. They say another way of doing combined calculation, adding all the wattage, that is 80 watts, 5 lighting point rated 10 watts. So how go? In order to calculate the total lights that is in, because it's 5 lights, and each of them is what? Is 10 watts. How do you get the total wattage of the light? 5 times 10, which is 50 watts. One television rated 50 watts. One satellite is rated 30 watts. 2 laptop computers that's rated 80 watts, which is equal to what? 160 watts. So you can see add all of that and see come back to multiplication of the time, that is 8 hours divided by 1000. I will explain to you the reason why that 1000 come in as time goes on. So first of all, let's just follow this, then we will now see do another calculation and see that they see another way of still arriving at this. So let's go. One ceiling fan rated 80 watts. So I have to convert it first of all to watts per hour before converting it to kilowatt per hour. This 1000 will be included. How many ceiling fan? 1. That is one ceiling fan. How many watts is the fan? 80 watts. How many hours? 8 hours. 8. So 80 times what? Times 8. That's watt times hour. You have converted it to watts per hour. So this now is, if you are not looking at this, 80 times 8 is what? 640. It's 640. 640 kilowatt, 640 watts per hour. 80 times 8 is going to give us what? 640 watts per hour. Why do we say watts per hour? Why would we put that unit watts per hour? 80, which is the watts. Power is calculated in watts, right? Hour, the time is calculated in hour. You understand that? So 80 times 8 is giving us what? 640 watts. Which in order to convert it to kilowatts per hour, what do? Divide it by 1000. So if we are dividing by 1000, we want to convert kilowatts per hour to watts per hour, what do? You times it, multiply by 1000. So in a place here whereby you are confused, I say this battery is 12 volts 200 amps. How many kilowatts is this battery? Kilowatt per hour. Based on what we just discussed now, how many kilowatts per hour is this battery?
It's 12 times 200.
Yes, 12 times 200. After the watts,
Wonderful. So another thing to also notice, not so like there is, so how many watts is this battery? How many kilowatts? Based on what we just said, how many kilowatts is it? 200, 2000, 2400. This battery is what? 2400. Approximately, you can just call this 2400 kilowatt per hour.
Okay.
You can still call this battery that. So that is other things that you still note. So back to what we're calculating. 5 lighting points rated 10 watts each, which you can just do 5 times 10, which is 50 watts. Then 50 times 8, 400 watts. You're going to be having 400 watts per hour. Abi? Then you now convert it to kilowatt, which is 0.4 kilowatts per hour. So the same thing for the television also and 2 laptops, 2 computers. So you can see say total kilowatt per hour consumed per day in that office per day 2.72 kilowatts per hour. Abi? So we're having 2.72 kilowatt per hour now. Let's now say what kind of inverter can you use. This is just easy way of calculating load in the house. For a start, before saying about what he said that you can just put all and know what you're calculating, but this is just one of the easiest way to calculate the amount of load and know the type of inverter you're going to use for them. Okay? So now you're having 2.72 kilowatts per hour. According to what he said, how many kilowatts per hour inverter or kVA inverter do you think can take a load of 2.72? Yeah?
Let's say 6 or 5.
Yes, 5 kVA can carry it effectively. So another thing to note, if not even that multiplied by 3, 60% of that inverter that you are going to get must what the load should run on. So how do you still get that 60% of the inverter? The inverter is 5 kVA, which is equivalent to what? 5000 watts. Or still the same thing as equivalent to 5000 volts per ampere. Why do I say 5000 volts per ampere? Unit of power is in what? Is in watt on joule. Abi, we are saying this inverter is equals to 1.5 kVA, or is still equals to 1,500 volts per ampere. Why did I say so? Multiplication of voltage and current, which unit are in what? Volts and ampere, which is VA, right? Are you understanding it?
Yes.
Understanding it? Volts per ampere, 1,500 volts per ampere. Converting that to kilovolts per ampere, which is the same thing as kilowatts per hour, because watts, ampere and volts. Let's just understand that. Let's understand that unit first. Let's understand that unit. So even any place you come across volts and ampere, or watts per hour, or volts and ampere per hour, you will know that yes, no matter what they are saying, you can still relate to the situation. Abi, so this inverter now is written here is 1,500 volts per ampere. I can go to some place and say, this is 1,500. I am seeing 1.5 kVA. Let me say, this is 1,500, and this one is 2 point something. This one is not far more higher than this one, 2 point something. That is not the main thing here. Now, to get the volts, to convert this to kilovolts per ampere, is what? What are you going to do? 1,500 volts per ampere. To convert it to kilovolts per ampere, what do you do?
Divide it by 1,000.
You divide it by 1,000,
1,000.
which is going to give us 1.5 kilovolts per ampere, which is the same thing as what? 1.5 kilowatts per hour. Have you understand that volts, ampere, and kilowatts per hour? Do you understand the reason behind that? Kilovolts and ampere, the same thing, being the same with kilowatts. Kilovolts per ampere is the same thing as kilowatts. Watts, because of the calculation. Because multiplication of volts and current is what gives us watts. Abi? So you can still say kilovolts per ampere or kilowatts. So it's still the same. So let's go back to our calculation. We are already done with this and say that what a inverter that can run the system effectively and efficiently is what? 5 kV. Okay. So now let's go back to our batteries that we're talking on, which led us to what? The battery that we're talking on. So calculating depth of discharge.